Hey guys, welcome to the channel. My name is Zen, and I've been helping students in their academic pursuits for the past 4 years now. I've since started making videos to further help students learn their physics and chemistry in the shortest way possible. If you do like these videos, do consider giving me a big fat thumbs up and subscribing to the channel for more videos like this. So without further ado, let's jump straight into the topic. All right, okay, so the first chapter we're going to do is units and measurements, right? So in this chapter, we're going to learn about different terminologies first, which is located right at the top down here. Okay, it's a scanned copy of what I have written. So the actual copy is right next to me, but doesn't matter. Okay, so what you all need to do is to have a landscape paper, get ready to write down certain things. You don't really need to copy down the micrometer, screw gauge, or vernier caliper. Just follow how I go through this information sheet with you, and what are the important things to take note of, and what are the common types of questions we're going to expect during exams, and then we are good. Okay, so first thing first, we're going to take a look at scalar and vector. All right, so scalar by itself is a physical quantity that only consists of magnitude. What is magnitude? Magnitude is basically just a number. So for instance, distance, 5 meters is a distance, right? It's how long it is, right? So that's a scalar quantity. Distance, 5 meters, no direction. But now if we talk about vectors, right, we're talking about a physical quantity that consists of both magnitude and direction, which means you are going to talk about displacement. 5 meters due north, 5 meters due south. So there is a direction involved when it comes to something like this. And then now we take a look at the period of a pendulum. Okay, the period of a pendulum is the time taken for the pendulum bob to swing from A to B and back to A again. It's basically from the start position, swing all the way to the other end, and come back to the place where it first started. Okay, so these are some of the terminologies that we're going to use today. Then now we're going to take a look at pendulum first. Okay, this pendulum here. What is pendulum? I know many of you don't know the formula to calculate the period of a pendulum, but you do not need to be worried about this because the formula isn't tested. Okay, the formula isn't tested, but what is important is to know what is in the numerator and denominator of the formula itself. So if we take a look at this, right, I'm gonna write it out for you. Okay, so if we take a look at this, we have the next part here called period of a pendulum, right? What is important here is to know the formula, and the formula is T equals to 2 pi square root L over G. Now, what is L? L is the length of the pendulum string. So for instance, if you have a pendulum, okay, this entire thing here will be L. Okay, what is G? G is the gravitational pull that is acting on the pendulum. Usually this doesn't change unless you're conducting this experiment on a different planet. Okay, what is pi? Okay, for those of you who already know your math, okay, pi is basically 3.14. It is a constant, it doesn't change. Okay, so the only two things that are affecting the period of a pendulum here is the length, okay, and the gravitational pull strength. Now, what are some of the trick questions that they can ask when it comes to units and measurements for this period of pendulum? Is that if they will change the mass of the bob or the pendulum bob, does it affect the period? The answer is no, because mass is not part of the formula itself. So if you want to put this down into simpler terms, when you increase the length, okay, you increase the period. Okay, when you increase the length, you increase the period. When you decrease the gravitational pull, you also increase the period. The mass of the bob does not affect the period. This is a crucial learning point right here. Okay, so basically this is for the period of a pendulum. And then another thing that they like to ask you, Zen, what's the best way to calculate the average period of a pendulum? Okay, so for this one here, very common question, what you usually do is to take the time for 20 oscillations. Okay, you take the time and then divided by 20 to find average period. Right, so this is for period of a pendulum. Okay, now we move on to the next part where we are going to talk about different prefixes. So basically we are moving on to part 6 first. Okay, we're going to take a look at this, different prefixes and what do you need to know. So for this part, we're going to talk about prefixes. Okay, prefixes are kind of like knowing how to change different units into like kilometers, into nanometers and stuff like that. I'll be giving you a very short example, a very brief example, easy example to learn how to convert units, because I know some of you have difficulties converting units or like don't know when to times or when to divide. Okay, so I'm going to help you with that. So first thing first, we learn the different prefixes, right? So there's the prefix, and then after that there's a symbol, and then after that there's a scaling factor. Okay, so the prefix itself, we will start from the smallest all the way to the biggest, right? So if you all know about the Marvel movies, the stock tag is always about nanobytes and nanotechnology. Okay, so the first thing we're going to learn is about nano, right? So nano is the smallest thing ever. The symbol is n, and it's 10 to the power of minus 9. And then after that, we have micro, right? And then after that, there will be this will be 10 to the power of minus 6. And then after that, we have milli, and then this is millimeters, right? 10 to the power of minus 3. Then after that, centimeters is C, and 10 to the power of minus 2. Deci is D, 10 to the power of minus 1. Kilo is K, 10 to the power of 3. And then after that, mega, which is M, 10 to the power of 6. And then we have giga, the biggest one that you need to know, G, and 10 to the power of 9. Okay, Zen, how do I remember this? So many numbers, so many different units. How do I tell? Okay, the most unique one that you need to memorize for this is micro. Okay, as in the symbol. It's just a funny U, okay, with an extra stroke. In Chinese, they call it shu, you know, 多一个 shu, right? So it's a U and a shu down there. So that is basically your micro. And then you realize that the most of the scaling factors are in factors of 3. Okay, not to be confused with the local gang called Salakau. Okay, but it's usually 369. Okay, you realize it's a 369 from milli, micro, nano, and then 369 from kilo, mega, giga, right? And then after that, the real things that you need to memorize is deci, centi, and milli, minus 1, minus 2, minus 3. Minus 1 and minus 2 for deci and centi, right? So the rest are just factors of 3. Right, I don't think there is much to take note here, right? This kind of stuff, I think you can roughly find anywhere. If you need to copy this down, you can take a quick screenshot just to take a look at this. And then after that, I'll move on to the next one, known as physical quantities. Okay, this is still part of the same place. Okay, physical quantities. What do I mean? Okay, in physics, right, there are physical quantities, there are basic quantities, then there are derived quantities. Okay, so at your level, we will be just talking about basic physical quantities. Okay, so how I remember this is always using this L, M, T, T, C, A. Okay, so we have length, right? Then after that, we have mass, temperature, time. Then after that, we have current, and then we have amount of substance. Zen, what is amount of substance? I never heard before in my life. Okay, so this one will be a very familiar unit to you when you do chemistry, and this is known as mole. Right, this is known as mole. Then temperature. Okay, let's start from the bottom. Current is in amperes, right? Time is in seconds. Temperature is in Kelvin. Mass is in kg. And length is in meters. These are your basic quantities. So you ever get an MCQ question asking which is a derived quantity, which is a basic physical quantity, these are all your basic physical quantities. Okay, everything here is a basic physical quantity. Right, very popular MCQ question, usually in the first three. If you don't see in the first three MCQ questions, then this is not going to be tested already. Okay, length, mass, temperature, time, current, amount of substance. Okay, easy. Okay, now we're going to take a look at this part here. Right, we're going to take a look at the micrometer screw gauge. Now, if we take a look at what it actually represents, okay, it is an ideal instrument for measuring the diameter or like small diameters. And the range, right, please remember this, guys. Okay, just remember the range is ideal from 0 to 2.5 cm. Many of you all tend to like, okay, micrometer is the most accurate, then I'm going to use it for a 5 cm diameter kind of thing. No, okay, you need to make sure that the item that you are measuring falls within the range of this micrometer screw gauge, which is from 0 to 2.5 cm. How accurate is it? It is accurate to 0.01 mm as highlighted, okay, down here, 0.01 mm. And now we take a look at the micrometer screw gauge itself. How do I read this? How do I read this? Very simple, okay? We take a look at where it first starts. It starts from 0. Every interval after that is a 0.5. So it's 0.5, 1, 1.5, 2, 2.5, 3. It stops at 3. It stops at 3. Okay? Now we take a look at where does it touch. This is the thimble scale, right? And it stops at 20. So this one here is 3.20. Okay, can you just edit this? Don't copy this. This is 200. So this is 3.20 mm. Okay, 3.20 mm. Now, how do I read the zero errors? Okay, usually the reading of the zero error comes before the actual reading of the main scale itself. So if we are taking a look at the zero error here, it's very simple. I always have a reference point when I'm doing this kind of micrometer screw gauge or vernier caliper questions, right? I always have a reference point. For me, the micrometer screw gauge reference point is always the 0 on the left. The 0 on the left. So basically, this is the 0 that I'm talking about. Okay, on the left, right? So this is a 0 I'm talking about. What do I mean by that? If my 0 on the left is higher than the 0 on the right, what do I mean? Okay, so the 0 on the right is one layer lower, one line lower, right? Which means I have a positive zero error of 0.01 mm. Okay, I have a positive zero error of 0.01 mm. Just by using a reference point, the 0 on my left, right, is one layer higher than the 0 on the right. So therefore, I have a positive zero error of 0.01 mm. Now we take a look at the other scenario where we have a negative zero error. So in this case, my reference point is still the 0 on the left. So I will take a look at this 0 down here and compare it to the 0 on the other side. This 0 on the right is 2 zeros higher. 2 zeros higher, which means I will have a negative zero error of minus 0.02 mm. Okay, if you want to use the 0 on the right as your reference point, by all means. By all means. But for me, it's very simple. If I'm higher, it's a positive zero error. If I'm lower, it's a negative zero error. Then students will then ask me, Zen, when do I subtract the zero error or when do I add the zero error? Easy. Okay, the answer is you always subtract the zero error. But the thing is, if you have a negative zero error and you are subtracting a negative zero error, so minus minus actually becomes plus, right? So I'll give you an example here. 3.20 mm. Let's just say it's a negative zero error. You must minus the zero error, right? So you will get 3.22 mm as your corrected reading. This one here, pretty simple. Always remember, you will minus your zero error. You do not add it unless it's a minus minus become plus kind of scenario. Okay, now we'll move on into the vernier caliper. Okay, so now we take a look at the vernier caliper. The range is from 0 to 15 cm. Please don't use it for anything outside of this range. Okay, 0 to 15 cm, right? And then after that, we have the accuracy of 0.01 cm. Pretty accurate as well, but not as accurate as the micrometer screw gauge. So how do I start reading this vernier caliper? Once again, take a look. Please, ladies and gentlemen, don't start reading where the ruler starts. Okay, don't start reading down here. This is not the correct place to start reading. It's not 1 point something. You need to start reading where the line starts. Okay, you need to start reading where the line starts. I will highlight this for you. Down here, this is where the line starts. So which means you need to start counting. 1.1, 1.2, 1.3, 1.4, 1.5, 6, 7, 8, 9. Then the line starts. So it's 1.9 something. Okay, 1.9 something. Then how do I know it's 1.9 what? You need to later look at which line is in line. What do I mean by that? Take a look at this. This is the 5th line and it's in line. This is the 5th line and it is in line. Okay, so what you're gonna have? You're gonna have a reading of 1.9. You get 1.95 cm. Okay, 1.95 cm. Right, 1.95 cm. Right, so this is the reading. Now, I'm going to show you how to read the zero error. Please take note there's something very unique in this chapter where we're going to learn about the zero error here. Okay, so this one, once again, I have a reference point. Okay, I have a reference point. So what do I mean by that? I will use the 0 at the bottom as my reference point, which means if I am to the right, can you see? To the right, okay? To the right, this is a positive 0 error. This is a positive 0 error. How do I know what is my 0 error? Okay, you see which one is the most in line? It looks something like this. So the second line is in line, so this is positive 0.02 cm. Okay, I repeat. I will have a reference point. A reference point is the 0 on the vernier scale, which is the 0 at the bottom. If my 0 at the bottom is towards the right, okay, towards the right, I know this is positive. Right, positive by how much? You see which one is in line. So the one that I see that is in line is the second one. I know when you zoom in, it doesn't really look like it, but it's the second one. Okay, so I'll get positive 0.02 cm. Now, listen very carefully. The negative portion of this reading is a little bit more unique. Okay, so if we take a look at this, the zero on the other side is towards the left. Okay, it's towards the left. What do I mean by that? What do I mean by that? It means it's a negative 0 error. Then, is it the same thing? Then after that, I count the line and see which one is in line. Yes, correct. But for a negative 0 error, you have to count backwards. Okay, so from here to here is one line. Here, second line. Here, third line. Here, fourth line. Okay, right? So we know that the 0 error here is minus 0.04 cm. Okay, you don't count the 10 line. You don't count this guy. Okay, you count the lines, the gap subsequently. So you have 1, 2, 3, and 4. Okay, you start from this guy. Then you count the gaps in between 1, 2, 3, and 4. Okay, the number of jumps. Okay, I repeat. You count backwards when it's a negative 0 error. So what happens? You start from this guy. You find the guy that's in line. Okay, you start from this guy, and then you start counting 1 gap, 2 gap, 3 gap, 4 gap. Right? So you know that you have a 0 error of minus 0.04. Once again, how do I know what's the actual reading? Very simple. So let's just take the scenario of 5B. Okay, we will take 1.95 minus 0.04 cm. Right, so you get 1.99 cm. This is a scenario where a negative becomes a positive. Okay, 1.99 cm. Now, like I said just now, I'll give you all a short example on how to do a conversion of units. Okay, So I'm going to show you a conversion of units example. Okay, so for example, I want to convert 40 grams per cm cube to kg per meter cube. Okay, I don't know what this is. Okay, I'm going to teach you how to do this. The very first step, right, is to create a fraction. Okay, so create fraction. What do I mean by this? So you'll be 40 grams divided by cm cube. You want to do this to kg per meter cube. Okay, the second one is to convert the numerator. All right, so we know that it's 40 grams. How do I convert it to kg? Okay, if you all need help, you will know that 1 kg is equals to 1000 grams. Okay, so if it's 40 grams, right, you have to just twist it a little bit. So it'll be 40 over 1000 kg. So I'll convert the numerator first. Then after that, I will convert the denominator without the power. You know, this is a cube, but I do it without the power first. What do I mean by this? Cm cube to meter cube. How do I do this? 1 meter is 100 cm. Okay, 1 meter is 100 cm. And then after that, we have 1 cm equals to 1 over 100 meters. Okay, so this is how you do it. Okay, this is how you do it. Then after that, we will bring in the power. Okay, bring in the power. Because this is cube, okay, because this is cube, it's going to be 1 over 100 cube meter cube. All right, so you're gonna need to put 1 over 100 cube meter cube. Okay, so this part here, if it's square, you square it. If it's cube, you cube it. Very simple. Just follow this and then you should be able to do both the numerator and the denominator. Okay, and then we move on. You put it all together. Okay, put it together. Okay, we put it together. So we have 0.04 kg divided by 1 over 100. And then you will get your answer. Okay, you have to meter cube this and then you will get the answer. Okay, so pretty simple, right? Do the numerator, do the denominator, put it together, and then you can do your conversion of units. Many students like to tackle the whole thing at the same time. Then you get very confused on what you need to do. So always do this very strategic approach of doing a numerator, denominator, and then doing the whole thing. Okay, so that is that for this chapter, units and measurements. What we have went through today is very simple. We went through the pendulum. We went through the units and we went through the prefixes and the basic quantities. Then we went through micrometer, screw gauge, and vernier caliper. And then after that, last but not least, we also went through how to do a simple conversion of units. Hey guys, thank you for watching all the way to the end of that video. I hope it has benefited you in some way. So if you really like videos like this, please subscribe to the channel and I'll be sure to upload more content like this to keep you guys going. I'll see you guys in the next video. Bye.